Good morning students. Today we'll see about the K-means clustering technique or a K-means clustering algorithm from unit 5. As we have already seen, machine learning algorithms are divided into two categories: supervised learning, unsupervised learning. We have already seen about the supervised learning algorithm. Now we'll see about the unsupervised learning algorithms. What do you mean by unsupervised learning algorithms? In unsupervised learning algorithms, we have just the collection of data with us, and depends on the similarity between the objects, we are grouping them, clustering them together, similar objects to be in a one group. Like so, the unsupervised learning algorithms has a clustering technique. So how to group that data items, how to find the similarity between them, it depends on it depends on which parameter or which thing we need to group the data items, which is given by the clustering algorithms. So clustering is the process of grouping the similar objects or the objects which are similar to each other. So we'll go for the K-means clustering algorithm, and we'll see the algorithm directly with the example. Here I have the example. In example, I have the name of the employee. For example, we have the name of the employees and the income of the employees in whatever thousand, right? K means just income in thousand. So here I have just the record of the salaries of the employees, that is 70,000, 20,000, 15,000, 50, 60, 70, 30. Likely I have the data, and the application is what I have to do with this data. I just want to group the people having low income and high income. So here I want two groups or two clusters. In one cluster I want the people which are having high income or which are in category of high income, and another group I want which is having a low income people, right? So this is my problem, and I will solve this using K-means clustering algorithm. Now we'll see directly what do you mean by K-means clustering. Here in K-means clustering, what do you mean by K? K is nothing but the number of clusters. How many clusters you want. Now here in this application, I want two clusters. One is low income people and another is high income people. Right? Now here, as we know, K is nothing but the two. And what do you mean by means? That we'll see later. Right? Now step 1. According to the K-means clustering algorithm, we have to choose the center of the cluster randomly any data item from your given data set, right? As here K is equal to 2, we'll select any two data items as the center of the cluster. There is no criteria for the selection of the center of the cluster. So here I am choosing 10, that is the first data item 10, and 70 as the center of the cluster. So here cluster 1 having a center 70, cluster 2 having a center 10. Right? Now here what I have to do, I have chosen 70 and 10 at the center of the cluster. Now next step is to find out the distance. Distance means the similarity between the remaining objects other than the centroid. Except the centroid, whatever the remaining data objects, we have to find out the distance of all these data items with the center of the cluster. Right? Now here how to calculate the distance? If the distance is less between the two data items, that means that are similar to each other. If distance is nothing but the difference, right? If I am saying that two things have very less difference, that means that are similar to each other. Just I am saying that light red and somewhat dark red similar to each other, because difference is very less between that two colors. So that means that these two colors are in a one group, that is a red, right? Group red. If one color is red, one is yellow, that means there is a lot of difference between the colors, right? There is no similarity between the color. So the difference is large and difference is less. If the difference is less, that means the distance is less, and that means the things are similar to each other. Then how to calculate the distance? Again, it depends on the type of data. If your data is numerical, we'll go for the Euclidean distance formula. What is the Euclidean distance formula? Distance is equal to square root of x2 minus x1 bracket square. Right? Now here we have to go for the step 2. Calculate the distance of first data item we have chosen as the center of the circle. Now we need to calculate the distance of 20. So distance of 20 we are calculating from 70 as well as 10, because 70 and 10 are the centroids of the cluster. Now here, as per our formula, we are taking square root of 70 minus 20 square, right? And the distance is 50. Square root of 10 minus 20, distance of 20 from 70 as well as 10. 10 minus 20 square root of that is 10. So I am getting two distances, 50 and 10. So among these two distances, 10 is less distance. That means 20 is similar to 10. So 20 will goes into the cluster which is having center 10. Right? Similarly, we'll calculate the distance of 15, 50, 60, 30 other data items from 70 as well as 10. So I have calculated here distances. Distance of 15 from 70 is 55 and from 10 it's a 5. Right? So 5 is less distance. As 5 is less distance, the 15 will comes into the cluster which is having centroid 10. Right? Similarly for 50 and 60. So if you compare the distances, we'll get the 70 including center. In cluster 1, the data items will be 70, 50, 60, and cluster 2, center is 10, data items will be 20, 15 and 30. Right? This is the iteration 1. In first iteration, we are getting cluster 1 having the data member 70, 50, 60. That means the person which is having salary 70,000, 60,000 and 50,000 are the high income category people, and others are the low income category people. Right? This is iteration 1. This is not our final cluster or a final group of the people. According to K-means, for the second iteration, you have to take the mean of the data items which are in a cluster 1 as the new centroid of your cluster. Right? So mean of these data items is 180 by 3 which is equal to 60, and mean of this another cluster is 75 by 4 which is equal to 18.75. Right? Now what I have to do in the second iteration, I need to consider this 60 and 18.75 as the new centroid of the cluster. Right? And I have to repeat the same process again, calculating the distance, checking the less distance and forming the new cluster. Right? So similarly, what I will do, I will calculate the distance of 10. Now I need to consider all the data objects because no one is center here now. Right? Earlier we have not considered 10 and 70 because these are the centers of the clusters. Right? Now the centers are 60 and 18.75, which are the mean of the data items which are the part of cluster 1 and cluster 2. Right? Now here, these are the distance of 10 we have to calculate from 60, distance of 10 from 18.75, again using same Euclidean distance formula. Right? And we have to repeat the process and we have to form the new clusters. Now suppose in this iteration I am getting the same clusters as I have in the previous iteration. Getting? Right? So if the cluster members are same in the second iteration also, that means you have to stop clustering again. You have to stop clustering again or repeating the process. What process we need to repeat? Calculate the new centroid and form the clusters again. So new centroid will be the mean of the data items. For example, I am not getting the similar cluster items. I am getting 10, 20, 50, 30 in one cluster using this mean as a center of the circle, and 60, 70, 15 in one cluster. So I have to go for the another cluster, another iteration, and in that iteration mean of these and mean of these will be the new centroid of the cluster, and I have to repeat this process till I get the similar clusters which I have in the previous iteration. Clear? This is all about the K-means clustering algorithm. Likewise, we have to form the clusters. Why it is called as K-means? Because K is nothing but the number of clusters and means is nothing but in the second iteration you have to take the mean of the data items as the center of your cluster. Right? This is all about the K-means clustering algorithm. Thank you.